everyone, this video is going to be talking about the differences between endothermic changes and exothermic changes. And since we're talking physical change this unit, I'm going to focus in on endothermic versus exothermic phase changes and applying those words to the 6 phase changes that we talked about in the past video. So looking here on our screen, what I see is the 3 phases of matter, and I'm going to sort of describe the phase changes as they relate to heat required. We know we need to either add heat or take heat away in order to make a particular phase change take place. For example, if I want to change this solid into this liquid, just looking at the arrangement of particles tells me going from low movement, very highly structured and organized, to a messier, kind of more movement allowed system, these particles have a little bit more energy, and that energy needed to come from somewhere. And in fact, it came from the addition of heat into that change, right? So the process of going from solid to liquid, or melting, required the addition of heat. And that type of change is what we call endothermic. The endo kind of meaning enter, and the therm piece meaning heat, because again, heat is just a form of thermal energy. So if heat needs to be added in to get from start to finish, you have yourself an endothermic change. So on this diagram, the second endothermic change would be trying to move yourself from liquid to gas, because in order to get from here to here, we need to add in some heat energy to try and get those particles to turn into a gas. And if you're really on your toes, then you know, of course, the change from solid to gas, or sublimation, is going to also be a very endothermic change, because we've got to add a whole bunch of energy to get these particles to be as farly spaced out as they are over here, with as few attractions as possible. And that's all moving left to right. So if we're moving in the opposite direction, we know there's a different type of change going on. If I want to calm down these extremely excited gas particles, I've got to have them release heat in some way. So if I'm moving from gas to liquid, the process of condensation, what I know is that I'm going to kick some heat out, kick out some energy, right, for the process of condensation. When heat exits as a result of the change, heat has to have left in order to get from our starting picture to our ending picture. We call that type of change exothermic. Exo being our exit or our release, and therm again being heat. So sure enough, there are 2 other exothermic changes on this diagram. One, when I solidify my liquid particles, because I've got to remove some energy, that energy has to be released as heat in order to make that change from liquid to solid. And of course, our big jump, deposition from gas to solid. I've got to remove a whole bunch of heat to compress these gas particles enough to get them into their solid phase. So we're going to use these terms endo and exothermic throughout the year, not just to describe physical changes like these phase changes, but also to start describing chemical reactions. If you think about heat flow, what you're going to notice, and the reason I chose the colors I did for these arrows, if heat is being put in, it has to be put in from some external source. Oftentimes that'll just be a hot plate or a burner or something, but you could imagine that heat coming from your hand. So if you have an ice cube in your hand, that heat is flowing from your hand to the ice cube, and your hand feels cold. Endothermic changes often feel cold because heat is flowing from your hand into the change that's taking place. So that absence of heat, that heat that is being taken away from you, we perceive as cold. Exothermic changes, on the other hand, they're releasing heat. So heat is flowing from the system changing into, say, the surroundings or your hand, and we perceive that as hot. So oftentimes exothermic changes, when we feel them, feel hot. So again, keep these 2 vocabulary terms in mind as we'll use them throughout the year.